Hello everyone. In last lecture I was discussing in details about marine equations. Based on these marine equations, today I will solve some problems on fatigue life prediction of welded joints. This is the content of today's lecture. Here first of all I will discuss about effect of welding on fatigue life. That means especially effect of typical types of weld joints in fatigue life. That means fatigue life in the sense endurance strength of the joints. Then I will discuss about stress concentration factor for some welded joint. This stress concentration factor is a theoretical stress concentration factor. Then I will solve some problem on welded joint subjected to fluctuating types of force and stresses. So, first of all we will discuss about effect of welding on fatigue life, how it is. So, here I am just showing some example actually for what is the effect of fatigue life on welding joints. First of all, it is observed that for low cycle fatigue, the material which is used for you can say welding application have a significant effect on what it is called fatigue life. But for high cycle fatigue generally it is observed that this material type is not playing a major role for a particular categories of material. Some of the example here I am showing, then it will be very clear to you. Here you can see I have shown here some welded joint which is done some aluminum alloy. Now, you know there are different types of categories of aluminum alloy are there. Based on this what it is called alloying composition, the aluminum is grouped into 7 different groups, you know, that is 1000 series, 2000 series, 3000 series, 4000 series, 5000 series, 6000 series and 7000 series. These are the 7 different series of you can say aluminum alloy generally popularly known to you. So, here based on these aluminum alloys, here I have shown if we do some welding operation for a 10 millimeter thick plate of different types of aluminum alloy, like you see 5154 H34 aluminum alloy. This also you should know little bit what does it means. 54 you can say 5154 H34 it is actually a aluminum magnesium alloy. This major composition of these types of alloy is aluminum plus magnesium. This aluminum percentage generally for this 5154 little bit I am just telling why, because you should know this thing, because as I am discussing here about this thing, that is why. Here generally aluminum percentage is around 96.02% and here magnesium percentage is around 3.5%. Okay. So, here H34 what does it means? H34 means it is strain hardened and stabilized by temperature heating. This is also some you can say heat treatment process which is generally strain hardened and stabilized by low you can say temperature heating. This you should keep it in mind, H34. Okay. This is so this is a material, this material of 10 millimeter thickness butt welding is done, and based on this butt welding it is observed that once we draw the stress strain curve means this is generally you can say fatigue stress and this is actually number of cycle. You can see it is started from here. If we draw for you see 5154 types of material, the curve which I am showing is this is curve number 1. Okay. So, another materials same thickness of plate and same welding types if we just do, then what happens, our what it is called stress strain curves is representing here by curve 2, and another and now you should know what is 6061 alloy. 6061 alloy is generally here the major composition is you can say aluminum plus magnesium plus silicon. These are the major composition. What is the percentage of magnesium here? Here generally percentage of magnesium for these types of alloy is 0.6 and silicon percentage is for these types of alloy is 1%. Okay. This you should keep it in mind. Now, another types of aluminum alloy also welded of same configuration, same thickness of plate, and the stress strain curve we plotted here, you can see. So, what we observe that this 3003 series, this is generally called aluminum manganese series. Okay. This is actually 3000 series aluminum alloy. Here the aluminum percentage is around 98.6%, whereas here the manganese percentage is 1.5%. Apart from this thing, in this aluminum alloy there is another composition, that is copper is also available. So, depending upon this aluminum with some other alloy, major alloying element, generally these are the aluminum alloys grouped. Now, what you can observe that around 1000 cycle, you see this material have a significant effect on fatigue strength. Like for 5154, its fatigue strength for low cycle range is higher, then 606 on T6 aluminum alloy is coming, and then the 3003 series is coming. So, from here what we observe that for low cycle types of fatigue range, generally you see this material play a vital role for what is called fatigue life or fatigue strength, you can say. Generally low cycle range, generally fatigue strength of the material for is depends on material type. You can observe that after 5 into 10 to the power 5 cycle, you can see this all the curves become asymptotic. That means this SM curve for all the joint geometry, or that means all the joint for different type of material, it's become asymptotic. Asymptotic means from here generally it generally convert to a straight line type. That means here after this, you see after this 10 to the power 5 into 10 to the power 5 cycle range, at this level whatever the stress is there, further reduction of stress generally does not affect, you can say, its endurance limit. What I am telling, understand? That is why here I have written V1 5 into 10 to the power 5 cycle, the curve become asymptotic, which indicating that the fatigue limit AC. That means where the curve become asymptotic means means you can say at horizontal line almost, then that limit is generally called is endurance strength for these types of aluminum alloy. After that, you also observe that if we increase further the number of cycle and reduce the stress level, then we will observe that this all the curves will become a single curve, you can say, you will become a single curve. What I am telling, understand? That means here I have written in second way. Further it is observed that at very high cycle region V1 10 to the power 6 cycle, all the curves merge together. Merge together means it is overlapping each other. That means you can say a single curve is coming here. After that you can say here I have written little bit wide band, but it should be narrow band, then it is a single curve is coming here, you can say. So, this indicates that whatever the single curve here it is coming, this indicate that the endurance stress, or you can say endurance strength, is almost independent of base material, especially in high cycle range, but will depends on well configuration. For a particular well geometry, generally you can say base material, you can say at high cycle 10 to the power 6, beyond 10 to the power 6 cycle, you can say your all the, for a particular series of aluminum alloy, all the curves become asymptotic. What I am telling, understand? That is why I have written here that this material does not play a role after 10 to the power 6 cycle, that means at high cycle fatigue life level. And but here one thing you will observe that this is for a particular types of weld joint, but for a particular types of material, if we change the weld configuration, then we will observe that it affect the weld strength significantly, especially fatigue strength or fatigue life significantly. How it is, that I will show in next slide. So, in this figure, what we observe that? We observe that for a particular types of weld joint, that means single type of joint, you can say single types of joint at low cycle level, generally materials have effect. Here you can write materials have effect on fatigue strength, fatigue stress, here I am writing. Materials have effects on fatigue stress for low cycle range, low cycle range means these materials play a role once the fatigue cycle is lower range, correct. Then your fatigue strength generally or fatigue stress is different for different types of material. But for high cycle level, what we can observe that beyond 10 to the power 6 cycle, you see all the curve generally of this SN curve generally merge together and makes a single curve. That means, for a particular types of joint, for different types of series of aluminum alloy, this generally you can say fatigue strength is independent of material type. But we will observe that for different types of configuration of weld joint, this fatigue strength is varying. That I am going to show in next slide. This you should keep it in mind. So, here I am showing just you see different types of joint configuration in this figure you can observe. So, from this figure you see for a particular types of aluminum alloy, this types of fillet welding is done. Okay. Now, you see for different configuration, what you see for these types of configuration, you will get one types of what it is called fatigue strength. Here I am just showing the endurance strength of that material. Okay. So, for a particular alloying elements, you see aluminum alloy here we see where generally for these types of joint configuration, if we do here you can say its fatigue strength is 30 megapascal. If we use, you see these types of configuration, here you see this plate is different, then this here generally two side two different plate piece we use, here we used a single piece. That is why in this case you observe that its fatigue strength is higher than you see this configuration. If we use these types of configuration of joint geometry, then its fatigue strength is this. So, if we increase that inner portion, inner part is larger, then its fatigue strength further increase. Similarly, here also another configuration, here also another configuration. What we observe that for different types of joint configuration, its fatigue strength is varying. Why? Because different types of joint configuration create different types of stress concentration zone, you can say, or stress concentration region. And for different joint, generally what happens, different joint also create different surface quality level also. That is why here I have written some important points that you should know. Fatigue failure generally due to formation of a small crack on the surface of the material. First some crack should be initiated, then this crack generally a subsequent propagation of this crack is generally creating this fatigue failure. First crack is required to initiate, then it need to propagate, and finally catastrophic failure is taken place, that you know. That is why here I have written here. In the case of smooth surface specimen, generally initiation of crack generally takes place in a long time, whereas if the surface quality is rough, then what happens, there is a chance of crack formation is high. Why? This roughness also depends on joint geometry, joint quality you can say. In case of a structural component, due to stress concentration, there are mainly location where the actual stress will be much higher than the applied stress. What I am telling, understand that generally in case of structural component, due to these different joint geometry and different types of surface roughness quality, the stress concentration will be different for those types of joint geometry and what is called surface quality. That is why here I have written, where the stress concentration of a joint is higher, there the chances of formation of crack is very easy. That is why here you can see some important point I have written here. So, in case of stress concentration region, generally crack can initiate easily. Why? Generally in stress concentration region, there the stresses is much higher than the applied stress. This you should keep it in mind, and this stress concentration can be 2 times 3 times higher than the actual nominal stress value. That also I have you can say normal stress value, that also I have already shown. So, you see that is why I have written here in the case of rough surfaces where the stress concentration is high, that means stresses is high, there the crack can initiate easily. And here another thing, so where the crack will initiate easily, its total fatigue life also generally then depends on what? Crack propagation time, because generally the fatigue life means starting initiation of crack time plus propagation times and its catastrophic failure time. In between generally whatever the time is there, this is generally called fatigue life. So, if initiation time will take more time, then what happens? Its fatigue life will be more. If initiation types of crack will be taken less time, generally in case of stress concentration zone, then what happens? Your fatigue life will be less for those case. That is why I have written. So, fatigue life of smooth specimen where generally stress concentration level is low or negligible, is that should be greater than fatigue life of notch and stress concentration points or stress concentration region. So, in a welded joint there are different types of defect we can observe and different types of notches also we observe, especially some important notch point I am just telling, like toe of the plate is one of the very critical zone of a fillet welding zone, fillet welded joint. You can say toe, you know very well, toe means corner point of that fillet weld, you see this is called toe. Here generally chances of stress concentration is high, because here generally suddenly abrupt change is occurring, here you see suddenly abrupt change is occurring. So, these are the zone generally where chances of stress concentration is more and chances of crack initiation is also more. Apart from this thing, there are lot of other defects also there in case of weld joint, which act as a defect as well as which acts as a stress concentration zone. That is why here I have shown for different types of joint configuration which have different types of stress concentration level.